welcome to an algebra tutorial video learning about linear inequalities. In this video, we're going to go over an example of a linear inequality word problem, talk about how to translate it into a linear inequality that we can then solve and use to answer the question. All right, so let's take a look at our problem here. We've got the maximum enrollment allowed for a school is 950 students. Currently, the school's enrollment is 768 students. But the trend the last few years is that the school population increases by 24 students each year. If the trend continues, here's our question, approximate how many more years the school will have a population less than the maximum. All right, so we have an inequality. There's the words less than. It's an inequality type of language, and I'm going to try and translate this into some algebraic symbols here. All right, so let's think about my population here. Currently, I know there are 678 students. So that's what I got right now. 768 students right now. And it says I'm adding to that every year. The population increases by 24 students. So after one more year, there are now added 24 more students to that. The next year, I add another 24. The next year, I add another 24. And it's a trend, and what I end up doing is however many years I multiply that, I'm going to use x to represent years. Let's go back and define my variable here. My variable for algebra, x is going to represent the number of years. The number of years the population is less. Population is less than 950. All right, that's what I'm trying to find. How many years will it stay less than that? Okay, so we've got 768 plus 24x, and I want to know, well, that's all got to stay less than this 950. Maybe I'm a school leader, maybe I'm on the school board, I'm trying to figure out how many more years do I have until I have to think about expanding the school or opening a new school or something like that. All right, there's my inequality. So let's just double check. Again, 768, that means how many students I have right now. I'm adding 24 students each year. That's why it's multiplying by x, because I'm figuring out, well, how many more years of multiplying, of adding 24 students, will I have to stay less than 950? All right, let's solve this out and let's answer the question. So I'm going to draw my line down. This helps me do things to both sides. I've got myself a two-step linear inequality. I'm going to subtract 768 from both sides. Let's work on getting x by itself. So 950 minus 768. 768 is 182. So now we've got 24 times x is less than 182. And what that means is just, well, I have 768 students now, which means I have 182 students left where I can grow and still be less than the max. But every year I grow by 24 students. So let's divide by 24 and figure out, well, how many more years of growth does that give me? So divide 24 leaves just x, and x has to be less than, I get 7.58, 3 repeating. All right, so there's my inequality. It's solved. That's great, but now let's go back and try and answer this question and make sense of what we have in this problem. So the question is, how many more years, approximately how many more years the school will have a population less than the maximum. So it looks like x to be less than has to be less than 7.58, which means in 8 years is not less than, so 8 years is not a solution. So 8 years would be too much. My population will have grown too big by then. So what I'm going to do, if I'm going in how many more years, and I'm thinking year by year by year, well, in year 7, so in 7 more years, I have to round to the nearest whole one. I can't really think of 7.583 years in school years. I mean, I could maybe break out the month, but I don't know if it's continuous enrollment. Anyways, in 7 more years, the population is still less than 950 students. There we go. We just answered that question. In 8 years, on that 8th year, I've got to figure something out because we'll have too many students. So for the next 7 years, the population will be less than 950 students. All right, hopefully that is a helpful example of taking a linear inequality word problem, translating it to the right inequality, solving the inequality, and then answering the actual problem that we're given.